should you be saying it at all? Okay, we are up.
Okay.
Are we though? Are we up? Yeah, we are up. There we go. Cool. But yeah, I guess what we're trying to pull off is more about the social aspect that solves the ills that you're talking about there, because they're a problem. And if I ignore the fact that developers being overpaid means that I'll have to take a pay cut, there's probably a lot of money to be made in the one upsetting the apple cart and getting rid of all the overpaid people. So, I mean, software devs always were out to snipe each other, ultimately, as we all blindingly pursue general intelligence. So, what's the harm in cutting loose a few jobs here and there?
Well, yeah, I mean, especially people that don't really want to be where they are anyway.
Well, that's the thing, right? And then they get stuck, and then you start them on projects because they're getting paid a salary, so you need to spin them up on something useful, and then that useful thing grows its own fucking arms and legs and starts demanding resources to carry on, and then it's all generally horrible. Yeah. Okay, so what do we want to do today?
What's on deck here? Oracles and Hook's mobile version of the site and time in Chainland. I remember you made a comment a while back about time in Chainland. I remember having conversations about this in the past, and
right.
I don't know if there's any sort of extra thinking that's gone on there.
No, not really. It's just, it's up to the validator proposer and the validator group to be okay with whatever the proposer said the time was. That time it needs to have a tolerance because of delays in the internet and whatnot. So, probably within a minute, but I'm sure that the validators, or we can make some algorithms that self-tune what that tolerance window is based on the performance of the network between the validators. So if they're very low latency, they can lower the window down to be, so that always over 2/3 of them agree. As the latency builds, they can just sort of agree on that window together.
Do you think everybody actually wants to... Sorry, so you're proposing that a timestamp has a delta built into it?
Yeah, well, for it to be approved by any of the validators, it needs to have passed the delta. Yeah, has to be within... There'll be some tolerance in there. That tolerance can be configurable, and it can also be variable.
Right.
So what that sort of alludes to is the fact that the validators need a set of messages that they all pass around between each other in order to make the blocks. And I do not want that message passing to be part of the wire protocol. That's an example of what I want to be part of the block protocol. So they basically share chains with each other, and then all that validator messaging takes place on chain, so that we can at least make the surface area of the wire protocol very, very small, making it easier to audit and secure, and it will change very rarely. So there ought not be dangerous security holes that pop up, because we'll be in chain land building on a secure foundation, and so our exploits will start to have a different signature than if we tried to make that message passing happen on the wire.
Right. So
basically the host chain comes into play a lot more. Like, it's actually, I think we both sensed that it was a powerful thing. We just couldn't quite figure out how or where, but that's one of the examples where it becomes powerful, because when you can simulate your message processing as part of state changes in chain land, it becomes a lot easier to reason about than on the wire. It kind of bundles up. Sorry.
The host is still basically in charge of the wire.
The host is absolutely in charge of the wire, yes.
Okay.
And the host can be differentiated by changing what type of storage, if any at all, you use for it. And so you can make a host that has no storage, just a RAM cache, if anything, and that blocking process can be used to operate hardware that allows more permanent storage for different chains. I guess what the idea that you mentioned a few calls ago, that you said that layers appeared like they were forming within the code base. It's in terms of like message passing between validators, that's sort of what I'm going for, where there's this layer of pure blockchain communication, which appears to simply cover public key, private key, encryption, discovery, packet loss, synchronization, action order, provenance, all those kinds of things, and that sits as one layer. Then on top of that, you deal with the message layer, which has more subtleties about it, like Byzantine fault tolerance. But because you're one layer up, your Byzantine operations do not need to handle that whole lower layer as well, and it makes it a lot easier to reason about, debug, and simulate.
It sounds like it would. So on the lowest layer, you're talking like that's the protocol layer, basically, right? That's like how you encode messages to determine things like action.
I'd say that's the wire. That's the wire layer,
right?
And the wire layer can be fulfilled by anything. So you could fulfill it by email messages, handwritten notes passed around. Like, the point is, the wire protocol doesn't care. It also doesn't care about latency, insofar as unless your validator group has a time-sensitive delta in their block making. That delta could be large, like it could be years long if you wanted, but the wire protocol doesn't care how you got the message there, which I think is a critical part of the system, because we don't care if it's the quick protocol, HTTPS, HTTP, we really don't care.
Right.
And most importantly, that allows us to actually run the full host chain within a blockchain itself as a simulation for our testing, because the wire is abstracted away.
Right. That's how it all ties into, like, so what I'm wondering basically, when you're talking about the wire layer, you're talking about the actual message format, and you're assuming like the messages will always be delivered.
Yeah, so, well, eventually, and there's a catch-up mechanism in there. Now, one of the changes since you last worked on this was that I removed all messaging from the wire layer. There are only interblocks. I may have to expand that with like 1 or 2 messages, maybe. I'm still not sure yet. It appears like you can get away with just using interblocks on the wire.
That's good.
It is good. I'm not sure it'll sustain all the way through, but if it isn't just interblocks, it'll be interblocks plus like 2 other signals or something, right? Like not very few.
Well, what do you think they would be? Start and stop kind of things, like
no,
boundary conditions?
They'd be like select range, or no, actually No, I don't need any more messages. Sorry, I take that all back.
Well, that's really good because I mean that means that you can focus the like message brevity entirely on the block kind of concept. Like your diff format can live on the block layer, and you don't have to worry about having like.
Oh, right. So
I mean,
all the optimizations for the interblock protocol immediately gained by the validator message processing system list of messages for that. Yeah. Yep. So I sort of just realized then that probably validator to validator, you don't need any catch up requests because the two validators sort of, you're like, this is my validator 1 chain designed to talk to validator 2, and over here this is my validator 2 chain designed to talk to validator 1. And each time they create a link to another validator, internally they are making a new chain to represent that other validator. And so because you're relying on the underlying protocol to guarantee delivery, that chain itself doesn't need any catch-up mechanism. So it basically gets started with a handshake that allows you to then begin sending interblocks between each other. And then any of the chains that you both host in common that you want to do catch-up on, those messages can be passed through that tunnel.
Right. So this is the ultimate kind of eventual state of. Sorry, I'm trying to catch up still. We talked a long time ago about like two-party consensus being like a special flavor of consensus. I'm trying to get my head around the circularity of like validators using chains to talk to each other, because those chains would need to be validated.
That's not two-party consensus. That's one-party consensus, because each validator, when it's talking to another validator at that lowest possible layer, is asserting what it said, and the other validator just simply has to take its word for it. The only thing it knows is the message format valid? Do the signatures check? Is it all in order? That type of thing. If they're not in order, then you're relying on the wire protocol to handle order for you, which is a reasonable thing to ask of the wire protocol. And if the connection fails too badly, you have to restart the handshake again.
Mm-hmm. I feel like that, like the sequence of events between validators, like putting that down in a document, like an interactive document, even like showing how the whole world bootstraps itself, basically, it would be a really, really handy document to have.
I don't know how to do that. What I've been hoping to do, because you might ask for that, there'll be like a bunch of other things where a diagram or a document would be useful. What I was hoping to get to was the Flow Creator app, which is basically a tool that lets you surface or graphically show state machines and their interactions. And if we can get that tool working the way I want it, it will be able to show the running internals of the blockchain itself. And so you could pre-record a series of interactions for the running chains, and then that's your doc. It's just that, the process of documenting it, I mean, it ends up changing on occasion anyway, and then I sort of, now the docs drift, and now it's, it's not that I don't see the value in what you're saying. I'm just looking for a cheaper way to produce it that stays live as well. That's all I'm after.
You want the drift to be in band.
In band, yeah, man, in band. And that's the same with business processes as well. So if we're able to use the same tool for modeling and keeping business processes in band, so that, as you like to say, the map is the territory, then there is no reason why that same tool can't be used to understand and reason about the internals of our code base too, because it's going to be running the same thing. So what's the difference?
Right. The reason I ask is because I'm just like I'm having trouble catching up basically, and like I'm trying to figure out a way to bootstrap myself back into like a more full understanding of the system, and I feel like stepping through the sequence of like how does something boot itself up as an authority, like a proof of authority kind of chain, and then start building all the different layers on top of it.
Well, I mean, that hasn't been built yet, so I don't know. That's why I can't really give you a doc, because yes, we have a design for it. Yes, it's sort of built to handle all that. But right now, my focus has been on single validator operations, because that basically makes it work like a traditional app, so that we can get the programming interface right. Because I think that everything hinges on, is the developer experience good? Like, not just good, but is it better than, like, does it somehow give you access to all of NPM plus make multi-threading like something you don't have to think about, plus distribution, redundancy, all of that by default? Like, that's really the thing I'm chasing. All these, what you're talking about with the validators booting up, yes, that's essential, but I consider that solved or solvable. Lots of people know how to do that. Lots of chains do that. No chain has this nice, clean programmer interface, which I think is all that matters in the end, I think.
Mm-hmm. But no, I mean, not exactly. I would say
not exactly.
Like you can have the prettiest programmer interface in the world. Like it matters how easy it is to deal with the politics of running a project, basically.
Can you elaborate on that?
That's where I think you're absolutely right about the Dreamcatcher ideas you've been talking about, is that like right now governance is the hard part of building an application, I would say. Like two hard parts really. One is knowing like the right tools to pick up and use in the thing that I'm building, because there's a discoverability problem, right? And the other is like when there's conflict about how to move forward, it has to be resolved. Like you have to deal with the conflict. You can't just like run multiple different experiments in multiple different directions and like eventually settle on the one that like feels the nicest.
Yeah, I hate that. It feels like I'm strapped to a bunch of suicide bombers, and we're basically running we can't move until all of us sort of agree that we're going to go that direction. And I'm like, what do you do when none of you actually know? It's like, can we split up and meet back later, or what? Right?
Yeah, and I think that's what leads to like the formation of tyrants in technology, right?
Well, you have to, right? Because it's like the tyrant gets to move like the one person, which is the only way to safely navigate the terrain. And we're sort of saying you could do that if you allowed a mechanism to multiverse things better, or at all.
Yeah. I think the second order problem that you'll experience from that is like the ingrained culture of development. Like, man, now I've definitely met a lot of developers that like throw their hands up and say, fill me with a task, because they've grown up in like tyrant land.
Well, they've been beaten down, and sort of those are the ones that will lose their jobs first, because what's that value, right? Like, we can outsource that.
Yeah, no, actually, that's a fair point. So that problem solves itself, basically.
I guess I just want to touch on the distinction or the difference you were making between the programmer interface and the politics interface. I think there's also, like, if I may explain more why I value the developer interface, it's also the fact that I want to encapsulate very powerful blockchain features in that same simple interface so that it's easy to pick up and run with. Like that's I don't know how to I still don't know how to. I'll just try and explain this messily because I don't have a clean way to say it. But making like the greatest blockchain in the world, which should be the goal of everyone who's trying to make a blockchain, because why would you have two blockchains in the world? Like, fuck, like why doesn't one do it all? You know, like why have two internets? There's no point. Like, just figure out your differences and merge. But the greatest blockchain isn't like, it's gonna look like something. It's gonna be about the programmer interface being just a breeze, and the only way that you're gonna get to that perfection point, no one group has enough anything to get it there. It's how do you get there and stay there? Because I guess we're just trying to get enough features and enough niceness in the interface to be up and running to get the self-improvement aspect of the Dreamcatcher going, because that's really the thing that wins. It's not any given set of features, because all these chains just absorb each other's features eventually, or like a new one comes along that represents a merge of several predecessors plus one or two new ideas. We actually need the system of continual internal improvement as the main part of the chain. So I'm sort of in a way saying the same thing you are, in that it's the politics part that's important, but at the same time, it's like the politics part needs to be solved so that we can approach the ideal developer interface for these powerful blockchain features. Yeah, that.
So how do you assess the quality of a programmer interface?
For me, it's about the ease with which I can reason about a program being written in this framework.
Interesting.
Sorry.
I would say that, to me, the best programmer interface is the one that allows me to model the most things in the real world without thinking about the program. What I mean is, like, programs are full of all sorts of bullshit. That's like, I wish I didn't have to like worry about shuffling this thing over here and like flipping that thing upside down and jamming this into there. And you know what I mean? Like a lot of my time programming is spent like with minutia that like I would love for it to just take care of itself. I would love to be able to like just talk about the domain and the problem and have that translate immediately into something that works. It's an ideal programming environment is one where it's as easy to write the program as it is to describe the problem. Right now, the majority of like the programming work, or what I'm finding, at least trying to adapt a program into a business, is like shuffling that information back and forth between the stakeholders who know the domain and like the programmers who know how to act on like domain modeling. Like the amount of noise that I need to cut out of dealing with the programmers in order to talk to the stakeholders, like everybody's mad because it's so easy to describe how you want this to work.
I think what the solution that I see coming for that is, part of the problem, I believe, is that every time you write a program, your object model or your domain model is always new. And it shouldn't be, because there's probably other programs out there that have a domain model that partially overlaps with the one you're trying to make. And so by making these serverless objects, so, you know, one blockchain per object of encapsulation, by allowing that to be shared, first of all, technically shared, but second of all, incentively shared, it allows you to anchor in your domain model, because a lot of the problems that happen are actually because of freedom. So I would assert that your problems from the impedance mismatch in stakeholder domain description, developer domain description, and the actual true what the domain description should be is a problem of freedom. The freedom to choose whatever you wanted. Whereas if you could say, well, there's this whole other domain model that's been made to model a user at a computer, and it's in use by these other companies. The libraries are there, the interfaces are polished, it all sort of stands up together, then you're like, we're going to start with that model because that describes part of our problem and we're going to build on it. And what it allows you to do is everyone who's involved can be like, okay, that's ground. And now our freedom has been reduced. We can only go so far from that. And that's what saves you the noise.
Right. You assert that something is the baseline that you're now working from. You assert
it allows you to inherit domains from other programming efforts, where the best domains are ones that have been shared between multiple projects that have knocked all the rough edges off them. And so you're like, well, clearly this is better than us just having a spitball and go at it, because these guys have already ironed out a bunch of reasoning problems that we'll otherwise hit. And what's more, what I hope is that those objects, when populated, are also shareable too. So like, if you had a bunch of, I don't know, I struggle to think of examples because pretty much everything can be treated that way. And so, like, I don't know, taxis, their model of cars might be inherited from Toyota's model of a car. Toyota was using that model for something different than what the taxi company was, but it is the same thing, so who fucking cares? And you start to actually populate the instance data as well. So if you've got a user who's, they use a computer terminal at work, then they go home and they use a computer terminal. Maybe the model of a user at a computer terminal can be shared, and so you can actually access more data immediately. Customer records being an easy one, right? You're like, customer's a customer, right? No matter which company's trying to build the model, if you can start to share that data a little bit, you can save a lot of programming time.
Oh yeah, I think so. I think especially if you can kind of draw out the spectrum of abstraction a little bit and like try and free out more of the stuff in the middle of the spectrum, stuff that's closer to like less concrete than the specific business information that a particular business is using to operate, and more like how they've drawn up the models of like how the components of their business interact with each other, I guess.
Right, because those models are where the pain comes from, and they're most likely wrong because they're most likely bespoke.
Right. Yeah, no, I think that's right.
Right. I really just this whole fucking gig is founded upon the fact that computer models all model the same thing. They all overlap with another computer model somewhere in some other program, and yet there is no mechanism to merge, deduplicate, share, and grow together with that. You have to fucking make the thing from scratch every time. And I don't know why we're all okay with that.
Yeah. Well, I mean, so what's the base of the inheritance tree?
Popularity.
Yeah.
Like, it doesn't matter, right? So these are some of the consequences of having a non-registry based uniqueness ability. So I can make a new object in the world and I can guarantee its universal uniqueness just by creating it in this system without getting to a registry. Like, that is the fundamental difference in what enabled people to be unbanked or to make a Bitcoin bank account with just a computer. It's the fact that I can make a collision-free address and broadcast it and without having to register anywhere. And so that ultimately is going to find its way into the foundations of our communication systems, because right now, all of them need a registry. Like a MAC address needs a registry. The IMEI on your cell phone, a registry. But it is coming real soon where it's just simply public key.
Yeah, I think actually it's a really interesting observation. The reason IPv6 is failing is because it solves half of this problem, but still requires a registry.
Right? If you make IPv6 not need a registry, you're off. You're away.
No, it's a really interesting observation. Okay. I know you want to get back into more concrete code topics.
I don't know. No, I want to get into whatever topics you want to get into, because I don't know the best way to help you understand. I'll answer anything you want. I'm more interested in explaining to you the far off reasoning and the far off features, because how things are today is merely a stepping stone to get there. I want help getting there faster.
Yeah. I think I get it completely. Here's an interesting way of like rephrasing what I'm trying to say then. Like, sometimes I wonder if these conversations like wouldn't be a little bit easier or more productive if they were mediated by code. Like, if we were having them over specific bits of code, basically.
Well, definitely the thing to be reasoning about right now is the Merkle array object and the map factory that forms all of the concrete objects in the system based on JSON schema.
Mm-hmm.
That's the thing right now. Is this something you want to look at now?
No, because I haven't had a chance to jump in and actually start coding yet.
Okay.
I'm feeling kind of guilty because I love talking about this, but I want to make sure that we're actually moving forward, right? I think it's easy to spin in circles and talk about
things
for a long time.
Very easy to spin in circles, but I wouldn't worry about it too much. Everywhere we look is an opportunity. So, yeah.
Right. So I do think that the thing I've been thinking about the most is getting into those models and trying to turn them into more of a descriptive system rather than a imperative system, and trying to break them along the same lines as the underlying models.
Right. The state charts.
I think the reason why I wanted to talk about oracles and channels and hooks is because I kind of want to get straight, like how to think about those pieces a little bit more. Okay. So I think that so much of the success of the system is going to be around how the channel model works. Actually, I think it basically is going to dictate how the pieces of the world are broken down, right? What are the ways that two pieces can talk to each other, right?
Yep. What
are the constraints we can place
how you can break down the world? Yep.
Just thinking about side effects and channels, and it's interesting that you brought up the host chain, because to me it sounded like you were saying the host chain almost acts like a side effect now.
It always did.
Mm-hmm.
It is technically the original side effect, and as a side effect it makes a blockchain that blockchain can have side effects that are carried out by the host chain. But the ultimately the host chain is a side effect. And
right, because the thing that you actually care about is the thing that you're building, you're modeling, right? The host is always there to just
the host is almost disposable. It's the model that you want to persist.
Right. And then I read a really interesting article talking about oracles and so I think the thing that I'm seeing a lot in Web3 conversations right now is this same kind of propensity to say that everything in the world needs to be a blockchain, right? Like if there's no boundary at all between the inside world and the outside world, the chain land and the real world, then that's how you kind of push all of this trustless, decentralized stuff out to every single corner everywhere.
It's the only way it's going to be. It's the only way it's going to be. And there's very few times that you can actually say something so final like that, because most of the time it's a maybe. This one, it's a definitely everything has to be a blockchain. It's the best programming model anyone ever came up with of how to model objects in the world, state to state, and in interaction with other objects that are transitioning state to state too.
Right. So I think that what the observation was that we live in a world where it's a necessary fact that many things are going to be out of band. They're not going to be happening inside of a chain. And at the end of the day, we'll always have at least some parts that are not actually blockchains. The users
you want to push that right out to the edge as far as you can. The mechanism for dealing with that I developed was the Pierce channel, which allows you to make a channel that is not a blockchain in itself, but to the recipient chain appears like it's a blockchain sending messages and receiving messages along a channel that it has no way to know it's being lied to. And that's the origin of how the world enters chainland, is through these Pierce channels. So ultimately, every IoT sensor would be, in effect, a Pierce channel that would then be pushing into a chain, and then from there on, once it's in chain land, you're good to go. You can do anything you want.
Right. So that answers one of my questions. Piercer is the newest evolution of the side effect conversation, basically.
Yes, it turns out that piercing allows you to treat inbound actions that come from out of band like a chain, but it also allows you the perfect mechanism to do out of band side effects as well, because it's two-way.
Right. It's just using a channel, right?
It's just a channel, and that channel mechanism allows for two-way asynchronous communication of any kind.
Right.
So yeah, modeling a side effect as just another channel that came from a virtualized blockchain works perfectly well. And then you enter chainland as soon as possible. It's not like a bit later on, it's coming in raw from the source straight into chainland.
Of course, there'll probably be eventually be lots of checks and layers between them in any real system.
Well, it depends, because certain things cannot be checked and are assertions, like a temperature sensor. I mean, the only way you can check that is to have a second sensor, but still the mechanism by which that data enters chainland is going to be the same for each one. They're just going to have different chain IDs. That's all.
Right.
So there's always a point where incoming data very much is an assertion.
Right. Yeah, I mean, of course, it's the same with users inputting stuff into the system too.
But it's all replayable, which is positive. So the framework I developed for web apps is that basically your clicks and your movements and your keystrokes are entering that Pierce channel and can optionally be logged and replayed, not just for historical reasons, but in real time, to allow someone else to view your session without any extra tooling. So if you make an app using this system, my goal is that, you should be able to make the functionality to shadow someone's session or have a shared session, and it's easy. Whereas like to do that with current tooling is a bit of a hula hoop dance.
Yeah, I think it's not just easy, it's trivial actually.
Yeah, because of this model, right? And I guess what I'm saying is that this model, I'm not saying that this is perfected, this model. I'm simply saying that there exists somewhere a model that looks like this that makes programming life remarkably easier.
Right.
That's the model we're chasing. And then to keep it at the forefront of its game, we are building the Dreamcatcher so that you can continually improve it. And everyone who has a good idea for how to improve it can get a fair reward for that, rather than starting their own project from scratch and competing, right? Like, we're not going to win this, convert the whole world to blockchain, unless we're presenting a unified interface, which means that everyone needs to be rewarded fairly so they don't have to splinter to get any kind of payment. It also causes all the scammers to sort of be pushed out to the fringes if you keep actually improving the single thing that you have, because there's not really a lot of opportunity for pump and dump.
Yeah. The only thing I wonder here in all of this is you need something to be fixed. Otherwise you can't, like, there's like a center that can't move if you want to be able to improve everything else about the developer experience and still have all the pieces interoperate with each other.
No. Just nah. All you need is the self-improvement mechanism needs to run on a fixed version of the protocol, and then it can be used to improve the next version of the protocol, which can then be swapped out underneath it.
So it's like a co-recursion kind of thing.
Yeah, but it can't happen simultaneously. It has to sort of tick-tock between the two. But, it's a simple example is the fact that Git, the code base, uses Git, the software, to manage their code commits, merging, and release cycle.
Right.
So they use the product to improve the product, which is what we're going for. It's not that hard to do, I don't think. Provided you have a blockchain.
Yeah, there's a bit of a difference though, isn't there? Hold on. Let me see if I can. Something is listening actively. No, actually, I guess not.
That was, I think, one of the fallacies that tripped us up with the host chain, was the fact that sometimes it's listening and sometimes it's speaking, and it sort of speaks and then it turns into listening mode where it sort of listens to what it just said. So it flips between those two modes of active and passive, and that's how the self-improvement mechanism can happen, where yes, there's a fixed relationship between where you are now and where you get to next. Like, you can only increment there, but over time you can increment kind of anywhere you like, and the systems that somehow lose or reduce their self-improvement ability will probably die off. So yes, there'll be a bunch of forks of the Dreamcatcher, but there's some incentive that I believe and I hope will continue to drive towards a single presentation layer, and lesser experiments will fail. I hope.
I mean, it would have to, right? Because, like, the only value that you get from, I guess, all economic value comes from cooperation.
Well, yeah, right, and that's sort of what the system's trying to allow you to channel, particularly channel it into itself. Yeah,
I mean, what purpose would you have? You're basically talking about the universe forking, right?
Mm-hmm.
It happens. I'm sure it can happen.
Yeah.
Like, it's just like it's not something you need to consider because, um, like once it's happened, like the people that are in the other half of the universe are no longer part of your universe.
Yeah.
And like all value moving forward would have to be something that you would get from the people that chose to stay in the universe that you're in.
Right.
I mean, I
It's a
know
little.
you're talking about merge mechanisms and stuff too.
Well, we want to build into this system the ability for you to fork and then continue to communicate with the fork. Like forking's built in, and it's part of the value generation system. In fact, it's encouraged. Whereas, for example, Ethereum forks do not talk to the other forks, the other
Yeah,
branches.
that's because the code isn't in band, right? Like
Well,
the
the
code is
code isn't in
in it.
band, but also the object model that they use is authoritative. It's not speculative, and it doesn't allow multiverse. So a multiverse capable chain is able to hold everyone's views together and to let them eventually reconcile and merge and, to your point, cooperate. Whereas these single authoritarian systems, which is how every system has been up until this point, up until Git was created, really, they do not allow you to cooperate because they can't help you reconcile your differences.
Right.
That's,
Okay.
I
Yeah.
guess, the key to this system is a formal way to identify differences, minimize them down to be just the pure difference, not like we need to start a whole company because of this one difference, and then ultimately reconcile and merge. Like that's the cooperative mechanism that we aim to formalize here.
Right. I guess that's kind of that's why the Dreamcatcher has to be an app, right? Like it has to be something running on the blockchain. It can't be the thing running the blockchain.
Yes, it must be subject to its own forces too. The Dreamcatcher is a project on the Dreamcatcher. Was that what you were
Mm-hmm.
meaning?
Yeah, yeah. I mean, everything's running on the blockchain. I get it.
Yeah,
The thing
yeah.
is, like, what is the piece that's missing from like the way that current blockchains run? Is that the decision to like pick up and be fill a certain role in the blockchain ecosystem is something that um, you don't mediate with like any kind of in-band governance or blockchain type structure, right? I'm really grasping at words right now. I'm sorry.
That's all right. I think I
You,
smell what you're getting
if you
at.
if you want to run an Ethereum validator, like that's fine. You can make that decision. It would be much better if you somehow registered the decision to do that, like inside one of the governance systems that's running on Ethereum, because like then all participation in the universe would be tracked by the universe, basically, right?
Yeah, yeah, right. Like you have to create an out of band system to register and cooperate with others who are running a validator, right? Whereas we're making a system whereby you can track and register and coordinate anything, including the validators that run the tracking registration systems as well.
Mm-hmm.
Like
Um,
our object model, I believe, can model any object, so you might as well.
yeah, I'm wondering what kind of attacks come from like not, you know, I'm not sure whether I'm right or wrong here, but to me it seems like the reason why there's a million pump and dump schemes out there right now in the current systems is because um, like anyone can pick up the code and just start running their own blockchain network basically with
Right.
their own rules on it,
Yeah.
and like and all those rules are there's like this like um, the value that they talk about blockchains representing is like I can create artificial scarcity, I can create uniqueness, I can create my own universe of like content addresses, basically.
Right.
That like everything is enforceably individual and unique. But the problem is that you can pick up the code and do the same thing, like again on a second blockchain, right? Like
Right.
NFTs are provably unique ownership of art until somebody sells the same NFT on a different NFT network, right?
Right. It's just a different kind of double spin problem.
Right. So like, how do you? That's something that I'm really curious how like, is it only incentive that stops people from doing that in your proposal for like how Dreamcatcher works? Like, if I were to pick up the code, run off, like not talk to anybody, start running it again, and build my own competing Dreamcatcher universe, like how how do I make those two things want to converge together?
That is what the mechanism we believe causes any two Dreamcatchers to reconvene is that the Dreamcatcher does not represent an instance, it represents a minimization of effort. And so for the Dreamcatcher to have value, it needs network participants. We are relying on those network participants to be self-incentivized or selfish in that they will not like to be stolen from. And so they would seek the best deal they could possibly get for themselves. And as a group, they would arrive at fairness because that's the only solution to that equation where all the participants can get the most for themselves sustainably is a fair system, we think. And so
Right.
anyone who makes their own version of the Dreamcatcher and keeps it separate from the main Dreamcatcher, thereby losing access to the already existing network of people who want to behave in this way, would be inserting some kind of a skim that would benefit someone else above the minimum possible. And our theory is that the participants of that Dreamcatcher will eventually become aware of the original Dreamcatcher, and because of the transparency of skims, will notice that actually they're getting less of a deal than they could. So why not just move over to the real Dreamcatcher, keeping in mind that each time a new participant enters, they are not joining your blockchain, they are running their own blockchain, and that blockchain is communicating, so they can easily communicate with both Dreamcatcher networks if they want. The envisaged mechanism is that anything above the minimum will wither and die if everyone can choose where they want to be.
It's like an energy equation. Everything's seeking the ground state.
Yeah, and it's predicated on the fact that our model is that people take our code and run their own blockchain. Ethereum is predicated on you run their code and join their blockchain. That's
right.
So different. Like our basic operation is a new fork. You enter the system, you are a fork. And by focusing on making communication between forks be trivial and run-of-the-mill standard operating procedure, anyone who makes a competing blockchain, their members are easily able to fork, move, jump around, join multiple Dreamcatchers. The Dreamcatcher itself, I imagine, is actually not a thing, but it's just this web of connections. Just like the internet web is not really a thing. It just looks like that because there's so much intertangling, but that's what I think the Dreamcatcher should be.
Right.
If people make competing versions and they alter our code and it works out better, we'll just simply absorb back their code, thank them for it, pay them for it, and continue to grow. So what's really the difference as a user? Which one do you want to be on? Well, if they're always pursuing minimum, right, it's going to be one. Only one.
Oh, okay, yeah, it just clicked. There isn't one.
Yeah.
There is always many. Yeah. The one that you go to most often is going to be the one that benefits you the most.
Yeah.
And like if the most people go to that one, then there's a massive incentive for everything to try and make that one the one.
Yeah.
Like to be as interoperable as possible with it.
Yeah. And our gamble is that fairness is the best one. That's the bit that we're not sure about.
Okay, so fairness, I think you probably have a fairly specific like algorithmic idea of what you mean when you say that. Like to me that word is ambiguous. It like fair is something that even in math, like it's really difficult to like properly talk about fairness because like fair is the state where everybody thinks that what's happening to them is fair, which means it's
probably never. But the more you can increase the transparency available to everyone, the more like fair is more like an asymptote, and you can get close to it. You can know when you're far from it. That's for sure.
Yeah. I don't know if you ever read this.
I do know some things about fair. I don't. I almost know that there is no such thing ultimately, but I do know that there's a lot of things that aren't fair. Now, for example, dispersal of reward based on a formula as opposed to a bunch of human-made exceptions is definitely more fair than like a cap table where you have shareholdings is a collection of assertions where you assert this person gets that, this person gets that. It is not formula based. It is not based on contribution. So already a rule based system is fairer.
Yeah, so long as everybody agrees to the rules.
Right, but it's easier to agree on the rules and understand why the rules calculated out to give you a certain outcome than it is to argue about assertions.
No, of course, yeah, 100%.
Right, and moreover, the more places that those rules are used in exactly the same way, the more confident you can be about getting a fair deal for yourself. Right, because by making it rules, it's very impersonal, whereas share tables are extraordinarily personal.
Yeah, definitely.
The second major thing for fairness appears to be not doing any allocation until after the work has been done.
Right. Yeah, so, that one I agree with for sure.
Yeah. So there's a set of patterns that we know are for sure fairer or fair-like, but actual fair may prove to be unattainable. It's not so much what we realized is you don't really need complete and pure fairness, particularly if you agree that or believe that pure fairness does not exist, or the cost of calculating it would outweigh the benefits of, like if you had everyone being treated close enough so that the difference between true fairness and what they actually got, it might cost you more than the gains to each individual to work out what true fairness is. It's not. Right. It's not so much true fairness; it's predictability. And it's predictability that matters. So we might, even if we said, look, here's our rules are that each line of code you make that gets merged gets, the total number of lines of code in the blockchain that ran to make that block, you get a proportion of the block fee based on the number of lines of code. Now, you and I can immediately sit here and come up with half a dozen ways to exploit that system. But the point is, it's predictable and it's already better than what the Ethereum Foundation offers you for making a pull request that gets incorporated into mainline Ethereum.
Right.
It's the predictability is more important than the true fairness.
Yeah, I would say predictability, but people are going to want to like change it too.
Absolutely. Well, we make the mechanism by which anyone can change it at any time. Mm-hmm. So it's sort of like, well, if it's predictable and you can change it by some formal mechanism,
there's still a bit of an assumption in there that like that your iteration would converge on something. I'm wondering how many like attractors, I guess, there is in that phase space. Like how many different like places are going to try and pull that process towards them, I guess. I don't know. Like if you looked at your rules and you thought of them each as like a variable in a n-dimensional space, I guess, like there's going to be points in that space that are more attractive and points that are less attractive. There'll be like points in that space where more people kind of gravitate towards, because it feels better for them, or it maximizes the amount of like happiness, I guess, on the system is what you're measuring. I don't necessarily think that space is going to be like there is one point that is fair. I think there'll be lots and lots of them.
I think it'll be changing over time based on cultural values. It'll change based on who the participants are. I think so long as everyone reasonably agrees that the system overall is trying to be fair and has these predictable properties, I think that's enough for people to be comfortable to work on it, because what more can you ask for, really?
Yeah, no, I mean, there's not a lot.
Right.
I think, but people have to think that everybody else thinks that it's fair too.
Right. If it's transparent, then you're some of the way there. Long term, I have a pie in the sky dream that a machine learning system could be trained to give you an opinion on how to allocate fairly. The point is, so long as it's not someone sitting there doing a Jeff Bezos and just saying 30% of that's mine, like, so long as it's like we're all under the same rule, it's basically the same spirit that caused laws to appear and be so widely adopted around the world. It was like, look, let's not have a bunch of asserted decrees. Let's first of all say that everyone's under the law, doesn't matter who you are, and then let's make a set of rules that are predictable. We all know that they're far from perfect, but they turn out to be better than assertions, which for some reason, inside every companies are basically mini dictatorships. No one's trying to make like democratic companies en masse. And what I'm trying to argue with the Dreamcatcher is that if you made a democratic company that had very low friction coordination mechanisms, you would find yourself as one large company, because all the other companies that pursued fairness would you become the same company because of the pattern that you're applying.
I think you're probably right about that. I think. I mean, I just am also thinking of it as like when you're attempting to solve a system of equations that you're writing, sometimes it doesn't converge at all. Sometimes, like, there is actually no attractor in the space, and there is no such thing that anyone collectively believes is fair.
All right, but even that divergent example still has some clusters of people that share that belief and simply put a firewall between them and the others. So all you've lost is this universal group, but you can still make a large group.
Yeah. And a lot of groups that have like low friction communication, even if they don't agree.
And people can jump between them or be in multiple groups. So have you really lost at that point? I don't know. But my point is that we are not trying to say what fair is. We are trying to provide a framework that offers the lowest possible friction to discovering it. And there are some properties that we know for sure need to go in there, like predictability. Because an unpredictable attribution system. I mean, you could make one for fun that was based on a toss of a coin, but even that is predictable or more predictable than a dictator.
Yeah. Yeah, actually, it would be, wouldn't it?
Right?
Mm-hmm. So it actually literally doesn't matter where you start here.
Yeah, pretty much.
Pretty sure.
That's what I'm trying to get at. Like, if you're pursuing that concept with these kinds of tools, we're all going to arrive at the same spot. That's what I'm getting at.
Or some multiplicity of spots that we choose to camp around and still communicate with each other.
Yeah. And interestingly, all those campsites appear empty right now.
Right.
So first to turn up and camp is probably going to have a mad party.
Yeah. So what else? Is there anything like the host chain implemented right now? I'm jumping around a little bit.
Yeah, no, that's cool. Not in its entire... Oh, like it? Yes, in Socket Factory. So Socket Factory is an example of using a blockchain to create side effects using the PS channel that ultimately end up communicating to a TCP socket. And so what I hope to demonstrate with that piece of code is that, yes, it's only being used for sockets, but surely, you can see from that I can use it for databases. I can use it for UIs. I can use it for kind of anything. That's how I imagine the host chain being.
One more thing I wanted to talk about on the topic of channels, piercers, side effects, oracles, is just slipping from my brain right now. Hooks. So you said something a couple calls ago about hooks being like a nice way to escape the oppression of determinism, basically. Is that yes. What hooks are? It's just basically wrappers around channels that do side effecty kind of things? Or do you have a more concrete kind of meaning when you say the word hook, or do you just mean it in the sense of...
The general answer is yes, but there's also... Hooks also allow you to do queries against past history. So that's not a channel action because that's not happening at the wavefront of the current block. That's looking back in time to previous blocks. So you could say that hooks are either a polite wrapper around interchain communication, or a polite wrapper around interchain historical introspection.
It bothers me that those are two different things.
They must be. They absolutely must be. The channel represents now. The chain represents past.
Right.
You can't ask for future.
Yeah.
So this is...
Obviously, you can't ask for future.
Be nice, but...
Right. So hooks, is that total? Is that all of the possible things that you would want to use hooks for?
Yes. Because we have marshaled the channel interface to allow you to both do side effects and receive side effects. You can't receive side effects while you're in the block making process. They must have already arrived for you to begin processing them. You can't. You can sit there and wait for them, but sorry, I confused myself. Yes, those are the only two. Yeah.
Okay.
Oh, yeah, because channels serve two purposes. They're both interchain and inter side effect. So you could sort of argue that there's three purposes of hooks. One is interchain communication, one is inter side effect communication, and the other is interhistory communication.
Yeah. When you're talking about doing a history query, then, like, walk me through how much time do you have left here?
I have until 3 p.m., which is
So 15 minutes?
about. Hang on, I think I booked longer. 3:30, so I have another 45 minutes.
Okay.
Life under the gun.
The when you're talking about going back into history, like what are the uses that? Sorry, how? I guess you want to specify ranges of blocks that you're interested in querying, right?
That turns out to be the killer feature, in my opinion.
Yeah.
Because queries allow you to do read-only lookups on arbitrary other chains, which allows you to greatly compress the amount of data that you can be processing in a single block production. So you can get the most recent state out of millions of chains, reduce it down to some end result, and then that's just one block. Whereas in our previous model, you would have had to communicate with those other chains, which would have taken impossibly long. Mm-hmm. By having this query interface, you can make the entire blockchain universe look like a really big MongoDB. And you can query it with the exact same language. Moreover, you can query it using GraphQL type expressions.
Right.
But the queries solve the problem of big chain. Big chain's not a great solution to solve. Like, making a big, huge object that somehow works is not a good idea. It's better to make lots of little chains and then query them.
Right. So you're not querying you're not querying your own history as a chain.
You can. There's no difference. So in the programming interface I made, if you don't specify the chain alias or chain ID, it defaults to querying yourself.
Right.
And if you don't specify a height, it defaults to querying the latest.
Right. And when you do specify a height, is it a range of heights or just like you're trying to find what was current at that one particular moment in time?
If you can ask for a height or a range of heights. Depends what you're trying to do. Hopefully, I really hope to basically absorb the MongoDB query language so that you can ask for across history and across chains, you can ask for conditions.
Right.
But by and large, the queries that you want the most are based on latest state of some other chain. Querying history is not that, in practice so far, I haven't found it that useful.
I think there's a lot of political uses for it. I think.
Well, yeah, but that's they're gonna be largely audit based or very specific type of workbench based type of queries. Whereas when you're making an app, it sort of matters a lot less what the history was as opposed to what current was. And I think, a testament to that is the fact that most databases don't let you query what things used to be. So, and they've worked just fine for 40 years. So something about programming means you sort of don't care about history.
I think, to me, I view that as, you've got the causality backwards there. I think that programming has not cared about history because the tools have not been available to it to do so. I think one thing that kind of stands out to me is I think people think of things like voting as being a very active current time thing. But I think there's a more like rich version of voting where you analyze behavior over time and like automatically ascertain or infer the opinion of people.
That is absolutely how we want to be. Like behavioral based voting is okay. So in terms of writing apps that actually pay attention to historical data because it's there and it's cheap to query, I will concede to you that yes, that is actually very important. And because we haven't had those tools available, they don't get used.
I think it's probably the reason why we haven't automated politics yet. Like I think the most like reasonable voting system out there right now, the most high bandwidth one, is the economy, spending money on things.
Yeah, but yeah, I mean that's where we want to get to is voting without tokens, voting by behavior only.
Right, which is like, being able to query history and infer that is like huge. You can probably sidestep having a token.
You're absolutely right. I mean, obviously, I put the feature in there, so I did think it was worth something, and I retract my comments about it being not that useful.
I mean, the thing is, you can simulate the same thing by actively paying attention every single frame.
Yeah.
Like the data that's coming through, but then you are stuck. You're stuck modeling like outside things that you're witnessing, right?
Yeah, it's better to be able to query after the fact than it is to track live.
Well, so I think like there's something even bigger here that's like if I have two politically distinct organizations inside of my company, right, and they're both writing code, and the code needs to interact with each other.
Yeah.
Like the thing that they'll end up making is each one will end up being an application that has inside of it a model of the other application. And that's how like application A is going to be actively paying attention to application B and storing data from it in its own internal data model system. Yeah. Right?
Yeah.
Like I think that that's probably the main reason for all bloat in all software that I've ever worked on. Is two people don't know how to communicate, like they don't know how to act on each other's terms, right? If you can query history, that's like saying I'm going to your model instead of I'm actively making a model internally of you that I'm using to keep track of you in the way that I want to keep track of you.
Okay.
I don't. That's it.
Okay. One of the continuous integration features I hope to apply is that when we push a new version of code for any given blockchain application in this system, we can take that code for that covenant and replay all the blocks that were ever made from a chain that had that covenant and make sure that all of the responses for all the given inputs are identical, or else we will need to bump the API version.
Mm-hmm.
So querying the history to give you safety of upgrades, it's not just making unit tests, it's that your external API, which is your actions that you accept and your responses to those actions, comes out the same, is one of the stronger tests that you can make, I believe.
Right.
I would have great confidence deploying a system where I said I was only making a patch update and I ran it against everyone else's calls to me and they came out the same. So I'm like, good to go.
Yeah, that would be excellent. That would be excellent.
Excellent, right?
Mm-hmm.
And then if it didn't work, you would have an exact JSON object to start with and an exact JSON object as a message, and you could figure out very repeatably why this thing came out different.
Yeah, anything that could remove the thinking from semantic versioning, I think is an excellent, excellent thing.
Anything that removes thinking in general appears to be a winner.
Yeah. Well, Tom, I actually gotta jump.
Okay, sweet.
It's been good talking. I
What was
promise
this?
one of these weeks I'm going to actually have enough time to sit down and get everything running.
Okay, well,
Um,
what I'm working on right now is the model system, with the
yep.
purposes of shifting to the database being diff based.
Okay.
So
Um, yeah, that seems like a real gnarly task, actually.
I
Just
know,
based on
and
what.
I was like putting it off for ages, and then like when I went to solve this Merkle tree problem, that was when I was like, actually, I can make everything be a Merkle tree, and it can all track its diffs from block to block, and that's way better than implementing a diffing solution as a separate kind of a thing. It's now diffing is built into the model system, and it's cheap.
Yeah, it's dips all the way down, right?
Yeah, all the way
I
down.
think.
So it's basically the model system is now block aware. So it's like you tell it that you blocked at that point. It merges all the diffs and calculates the hash, reusing as much as it can from previous times to be quick. And then from that point on, it's tracking the diffs until the next event where you like block. So optimizing that and getting our heads around that is basically the seems like the game, and I don't imagine we need to do much more than get that piece right. What else does the model system need to do?
Yeah, I guess. I mean, that's something that I don't know how to do. Like, you want to find a point to cut over and start writing applications rather than protocol stuff, right?
Like, when is it done enough to start doing other things? You mean?
Well, just like it seems like the layers could still be um, loose, you know? Like, it seems while you're building it, like it's not always clear what things need to be separated off into what layer.
Oh,
I think
right.
you probably.
This is for sure. This bit is for sure because we know that we have blocks, and we know
Right.
that blocks, because they have to be signed, have to be hashed, which gives you a finality about them. And so the model layer that deals with block formats and what is the acceptable format of the next block, that is absolutely for sure.
Okay.
We have lost the blockchaininess if we've lost that.
Right. But then, yeah, okay, I don't know. I think,
Are you saying
is
like just keep in mind that it
there a
might
doc?
change still?
Sorry?
Were you saying basically keep in mind that it might change still?
No, no. What I'm saying is, like, is it as big of a deal as it used to be that interblock itself, like, finds the correct boundary for itself?
What do you mean boundary?
Like, the right features to be inside of that piece versus inside of the Dreamcatcher.
Oh, I feel like I've found them.
Okay. And, like,
Particularly,
have you.
particularly with that ability to, by being able to control arbitrary hardware as a chain, like TCP sockets and the API gateway in AWS, that very much allows the code base of Interblock to reach finality because all these other things are not part of that code base, they're covenants.
Right. Have you got this written down in a document? Like, what are the layers and what are the boundaries between them? Because I keep forgetting. I keep having these calls, and then I keep reading some code, and then I keep asking the same questions again.
Um, No, but in the schema definitions of every piece of the block, there is a description that says what it does.
Okay.
And apart from that, I mean, how would I go about what would that document look like and where would it be?
Yeah, yeah. No, I mean, that's an open question. I'm not. um, I'm really right now just trying to meander my way through all of this to the point where, like, I'm not wasting time picking it up and trying to add stuff to it. Right?
Okay. I haven't got the feeling you've wasted any time so far, and I never got the feeling like you did that in the many years we worked together either. So whatever way you need to feel comfortable about going about that, I'm sure it will be optimal.
I just think there's it's very, I think, great to see that like so much of this is stuff that you've worked out and like that you've written,
Yeah.
right?
Yeah. I believe I've solved all of the problems that we had outstanding. If you can remind me of a problem that was outstanding that I haven't solved, I would appreciate that. But the fact that I can make a full-blown app makes me feel like all of the philosophical problems have been solved. Haven't all been implemented, but have been solved. When instead we knew we had unsolved problems when we were working on this. Please remind me if I've missed something.
Yeah, I mean, I can't think of any, right? All the unsolved problems for me were like always the host chain, basically.
I think I got it. Do you think that what I showed you in the socket factory represents a solution to the host chain problem?
Right.
I mean, it is a blockchain operating the hardware.
Right.
That's sort of the host chain, right? Like, fuck.
Yep. Yeah, I mean, the only thing is the host chain. The host chain does get a little bit, there's that loopy part of it where like, is it running itself or is something else running it? Like, there was two big things that stood out to me when we were talking about the host chain. One was, to what extent is it actually manipulating the to and from of where the messages are going? Like, how much is it in charge of the channels of its children? And how much is it in charge of the channels of itself?
It is not in charge of the channels of its children at all.
Right.
It is technically not in charge of its channels to itself either. Its side effects are in control of its channels.
Right. So it is still kind of inverting control. It's still letting the machine tell it what to do.
Yeah. The point is that it's a standard piece of code that doesn't care how it's running, whether it's being run inside a block or whether it's running blocks. It's the standard library. How you fill it in with different hardware and all that, it's up to you.
Okay. Okay. I think I'm ready to start deep diving. Hopefully I can find some time to do it this week.
Okay, so I'll continue. I've had a little less time than I had expected, but I will continue on the transition to the array-backed model system. I'm still convinced that that's a go. It may need some performance tuning, but it's certainly better than what I had previously. Runs a lot faster, has diffing built in, blah blah blah. So that's what I'm doing. And my goal is to be able to import 20,000 customer records in under 5 minutes. So that would be a total of around about 100,000 chains in under 5 minutes worth of import data, running on a real DB stored to disk.
Okay. Sounds good to me. I think I'm still interested in jumping into the state machine that's running the models and seeing how I can.
Yeah, it's definitely wrong. It is not model-based tested. It's end-to-end tested. It doesn't use model-based testing. I've done something wrong. I don't know what. It is a philosophical problem that I have there.
Well, I mean, there's always escape hatches. That's the first thing that I would say to you. I think like every single language, every single code ecosystem that's ever been made has the hope that it's the one that's going to solve some things needing to be imperative and fiddly, right?
I know it smells to me like I am damn sure that I have gone way too imperative on how the interpreter processes the chain.
Yeah. Yeah. And I mean, I think it no matter how many times I tried to write it, that happened to me every time too. So, but we'll get there.
Yeah.
Okay.
Cool, man. Great talking.
Yeah, you too.
I will see you later.
Yeah. Bye.